And now finally, we're at this last question now. And they want us to determine the position vector OQ. The position vector OQ, we can find that by writing down that them give a PQ. PQ is OQ minus OP. That's PQ. PQ is OQ minus OP. This is vector PQ. So if vector PQ is equal to OQ minus OP, then to get vector OQ is going to be PQ plus OP. So vector OQ is equal to PQ plus OP. PQ is -1, 2, and vector OP is 3, 4. We add them together, and then it's a -1 plus 3 is 2, and 4 plus 2 is 6. That's vector OQ. Then it says show that OQ is parallel to RS. To show that OQ is parallel to RS, well, that's easy to show. OQ is equal to 2 and 2, 6. And I can write 2, 6 as 2 times vector 1, 1/3. But the vector 1, 3 is just RS. So this is just 2 times vector RS. So clearly they're parallel. Here it is, they're parallel. All right. So OQ, so the ratio of OQ to RS is 1 to 2. Clearly they are parallel. All right. They are parallel, of course. Then now this asking now for, it says X, Y, and Z are triangle and M is the midpoint of Z. It says express the following now. It says XZ. All right, so I always like to have a diagram to see what I'm doing. I know that from X to Z, X to Y is A. All right, so I'll go from X to Y. I know that this is A. And then from Y to Z, I don't know where Z is. I'm just making up a diagram. I know that from Y to Z is B. All right. Then I want to go from X to Z. To go from X to Z, I can go from X to Y, then Y to Z. So this is just equal to A plus B. A plus B. Now I need to go from M to Y. Where is M? M is the midpoint of XZ. So XZ is somewhere right here, and this is M. So to go from M to Y, to go from M to Y, to go from M to Y, I can go from M to X, then I'm going from M to X, and then from X to Y. So M to Y is M to X plus X to Y. No issues. But MX, to go from M to X, is like it's a half of Z to X. A half of Z to X. So M to X is a half of Z to X. The half of Z to X. And going from Z to X is minus XZ. This is a half of minus A minus B. This should be plus. Why this look like times? This look like a times. That should be plus. plus xy now, and xy, which you know xy is a. So all of this works out to be minus a half a plus a is a over 2 minus b over 2. So if you want, you can factor out the half if you want and write it as a half a minus b. Half a minus b. And that's m to y. Nice and easy. Now we reach matrices now. It says determine A inverse. Determine A inverse. To find A inverse is equal to 1 over the determinant of A, 1 over the determinant of A, and the determinant of A is AD, which is negative 2 minus 0 times the adjoint. So you interchange A and D, so you have 2, negative 1, then you have 0, negative 3. All right, so that's the adjoint of A. The inverse of A is 1 over the determinant times the adjoint. All right, now it says show that A inverse times A give us the identity matrix. So A inverse is 1 over negative 2 times 2, 0, negative 3, negative 1. And when you multiply it by A, matrix A is negative 1, 0, 3, and 2. And we're going to multiply them together. And what we're getting is negative 1 over 2 times row by column gives negative 2 plus 0 is negative 2. Then row by column gives 0. Row by column gives positive 3. Positive 3 minus 3, which is 0. Then row by column gives negative, that gives 0 minus 2. Then we multiply the negative a half times negative 2, 0, 0, negative 2. Negative half times negative 2 is 1. Negative half times 0 is 0. Negative half times 0 is 0. Negative half times negative 2 is 1. It's like your 1, 0, 0, 1. And that's good. Nice. Then they ask us to find the value of a squared. Find the value of a squared. A squared is equal to a times a. That's what is a squared. A squared is the matrix A times itself. So we're going to multiply a times a. A is the matrix negative 1, 0, 3, 2. So write down negative 1, 0, 3, 2. Then you have negative 1, 0, 3, and 2. Multiplying these two matrices across, what we're going to get is, doing it in one step, row by column, that's negative 1 times negative 1 is 1, plus 0 is 0, so that's just 1. Row by column, negative 1 times 0 is 0, then 0 times 0 is 0. That's row by column, 0 plus 0. Now row by column gives negative 3 plus 6. Negative 3 plus 6 is 3. Then row by column gives 3 times 0 is 0, 2 times 2 is 4. So that's a squared, 1, 0, 3, 4. Then it says explain why the matrix AB is not possible. Now A is a 2 by 2 matrix. Go write that down. A is a 2 by 2 matrix, and B is a 3 rows, 3 by to matrix. But the number of rows, the number of columns of the first matrix must equal to the number of columns of the second matrix. But this is not the case. All right, that's why. All right, so the number of columns of matrix A is not equal to the number of rows of matrix B, and so AB is not possible. That's the reason. Number of columns of matrix A is not equal to the number of rows of matrix B. Then it asks us to work out what would be the order of B times A. Now, in order to know the order of B times A, B, as we said, is a 3 by 2, 3 by 2, and A is a 2 by 2. A is a 2 by 2. And so the result is going to be, this is possible because the number of columns of B is equal to the number of rows of A. Then the result is going to be a 3 by 2. So BA is a 3 by 2 matrix. So BA results in a 3 by 2 matrix. Nice. And that completes this question. Nice. So stay tuned for more. Just remember to subscribe to help the channel grow, to see the features get better and stuff like that. Just subscribe to help the channel grow. See you with more solutions.